So when you can train with more tokens, it means your model can learn more things. So think of tokens as an alphabet and think of parameters as vocabulary. So if you have a model that's trained on a small alphabet, then it can't really learn much. So let's say, for example, you train it on English alphabet. Well, there's German, there's Russian, there's Hindu, there's Chinese, there's Japanese, there's Korean,
Yeah.
right? If you wanted to learn everything in the world, you would need to include all those other alphabets.
Okay.
If you didn't, it couldn't learn those things, right?
Welcome to Practical AI, everybody. My name's Jeff. I'm here with Peter Lynn. Practical AI is brought to you by Pocket AI. Pocket AI is a tool you can use to edit the weights of your model. With Pocket AI, you can prune over 60% of the weights in your models while increasing accuracy. You can also find us on Spotify and be sure to listen to us in 2x speed because Peter and I listen to ourselves in 2x speed because we can't stand how slowly we talk. Peter, today we wanted to talk a little bit about the open source win that just happened, but also we had a couple of fails. Tell us, or maybe one fail. What was the fail that you recognized this week?
Well, there's a couple. The first one is OpenAI released their agent thing. So it took longer than expected. Everyone thought they would have released it probably back in March, February, but they didn't. And now they finally released it. But from what people have seen, they're actually spinning up a VM and then running the agent in a VM, which in theory sounds safe and that's the secure way to do it. But the downside is if you spin up a VM for every agent and you have five agents working together, that's five VMs, which anyone that knows cloud stuff, that's very expensive to run. And it's also slow because you have to spin a VM up, feed it the data, have it do its thing, and then when you're done, you spin it back down.
So in this instance, the sort of containerizer or VM is probably one of the safer ways to do it, but
Yep.
it's expensive and slow.
Yeah, I mean that's the common complaint in cloud is spinning a VM up takes at least 2 to 3 minutes.
And are they selling past this and just saying, yeah, it's more expensive because it's safer?
Um, I don't know,
Yeah.
but it's not going to scale. That's for sure.
Oh yeah. Well, there's that too. Okay, and what about just usability? Obviously, it's got a little slowness to it, but Agent Force has
Right.
their, our Salesforce has Agent Force, Agent Space with Google.
Right.
We've got some open source ones like Manus AI. So,
Right.
how does this one look and feel just to the user?
So as far as I know, I believe Claude also uses a VM, but they run all the agents in the same VM.
Okay.
So that's better. So okay, yeah, if I'm using Claude and I spin up a VM, that's one VM. That's gonna run everything, all the agents in that same one. So it's not as expensive as like spinning up multiple VMs. So now, but we don't know for sure that OpenAI is doing that. That's what some people have observed. So they think that's how it's being done. But until we get confirmation, we don't know for sure.
Okay.
I hope they're not doing that because it's the most secure way. It really is, but it's also the slowest, least scalable way.
Got it. Okay, well, I think there's still a lot of tread on the tires yet on the whole agent side. It's getting a lot of momentum, but I'm seeing more solutioning coming from sort of the process side, working towards the agent than just techie agent stuff. So we'll get into that another time. But um, on the open source side, we have kind of a big win coming out of China again.
Yeah.
Tell us what the Chinese have figured out and how it's comparing to other LLMs.
So this is Kimi K2, which is another model. And people are comparing it to DeepSeek, and they're saying that this is kind of the DeepSeek 3, except it's not really the same group. It's a different group. And so they trained a new model that has a trillion parameters, and only a fraction of that is active at any given time. I think it's like 32 billion. But the big thing is they trained it with a trillion tokens. And the nice thing from their report was their loss in error was kind of smooth. It wasn't normally when you see these reports, the loss kind of is spiky and there's some oddities where as it's training it starts to go down, but then there's some of these like weird spikes where error and loss just goes crazy, and you're like, what? Like no one knows why it happens, and then you just try to fix it.
So this is that loss graph you were seeing. Explain why this is kind of important and something I noticed, and I'm not an expert in this, but I noticed that it sort of trended and kind of plateaued almost, and then it continued to, you know, improve really because it got lower.
Yeah. So typically, this is kind of the ideal that you want to see. Because over time, it's going to do this thing where it goes up and down as it's trying to find the right values for all the weights and all the tension mechanisms. And over time, you want it to generally trend down where the loss and the error goes from something that's like over 100% to close to like 5 or 10 or 0%, ideally. I mean, it's never at zero, but in general, you know your training is doing well if both the accuracy goes up and your error and loss have a nice smooth curve down.
And then what is this little section here?
So it looks like it was training and it did plateau for a while there. And then it looks like they probably adjusted it, right? So there was something that was going on that caused it to plateau. So they probably adjusted the training and then allowed it to continue.
Okay. And just out of curiosity, if I've got a trend line that looks like that, why stop? Why not keep going and see if it'll go to zero?
It'll never reach zero, actually.
Well, I know. Seems like they cut it off a little early.
Yeah, so
Or
everyone pretty
maybe the
much,
accuracy was also starting to fall apart a little bit.
yeah, they didn't include it in that video, but the report might have it. I don't remember.
Yeah. Um, and so then another thing that kind of was in this, and we have three videos that we'll share so that you can watch these if interested. But and you mentioned it earlier, this trillion parameter thing. So that seems like news, right? In that it's kind of training with the number of parameters that you would for one of the closed models too. Why is that a big deal, and what is that? What does that mean, generally speaking, when you can train with more tokens?
So when you can train with more tokens, it means your model can learn more things. So think of tokens as an alphabet, and think of parameters as vocabulary. So if you have a model that's trained on a small alphabet, then it can't really learn much. So let's say, for example, you train it on English alphabet. Well, there's German, there's Russian, there's Hindu, there's Chinese, there's Japanese, there's Korean,
Yeah.
right? If you wanted to learn everything in the world, you would need to include all those other alphabets.
Okay.
If you didn't, it couldn't learn those things, right? And then the dictionary is like what you can create from the alphabets that you have. So the tokens is the alphabet, and the parameters is the dictionary.
And when we got introduced to ChatGPT, do you recollect how many tokens they had trained on?
I think the early ones, like 2 and 3, were like a million.
Also, it was pretty small,
Yeah.
relatively speaking. Yeah.
Right, but that's because back then we didn't have the really nice hardware we have now.
Yeah. Okay. So one last topic then in this space that I wanted to get into, and that is the Kimi K2. One of the highlights of this is that it attained a level of of it was comparable on multiple sort of baselines against
Yeah.
all of the big boys, right? And and that's impressive. But even more impressive maybe is that it did it without reason. They didn't embed the reasoning element into this. So explain a little bit how the reasoning thing works and um, if you can guess how they pulled it off, and or if it would be even better if they baked reasoning into it.
So I think the reason they pull that off is because they're using a mixture of agents, and so they've trained different versions of models, and so that gives them the ability to do better on benchmarks.
And the
Benchmarks
agents
are
are basically like guiding the prompts. So when you prompt it,
so it's
it's going to.
basically a specialized version of the language model. So they have 32 different versions.
Okay.
So the
So
total
they'll
amount
have
of
one for
time,
math, one
yeah,
for physics, one for history, etc.
yeah,
Okay.
yep.
And then just step back and explain how they normally do reasoning when they train these things and run them.
So the non-technical term is just give it more time to think. So you just tell the prompt, hey, when I first ask a question, you're gonna generate multiple responses. You're gonna compare the responses and pick the best one.
Okay. And so there's both the time element, but there's also a sort of prompt, a RAG prompt engineering element to this as well, right? Where you
Yep.
basically load up the prompt with stuff and uh, humans are involved, they're not. Like, how does that work?
So basically, when you do alignment, you give it prompts and then you feed it your RLHF data set. So the reasoning prompts are all the same. What differentiates between one model and the next model is the data set.
Okay. And so during training, you're getting the humans are involved in at least uh, giving it feedback on the prompt side of it. So basically, did you train and get the or refine and get the right response that we expected?
So the human side is just creating that RLHF data set.
Okay,
Like,
okay.
here's the question, here's the response.
And the human doesn't measure the response, or the human is involved in training the model how to select which
So the
response
human
was
part
best.
is really designing your RLHF data set. So like you say, here's a math problem, here's the steps I expect you to see, and here's the answer, right? You use the same prompt. That's a reasoning prompt. You give it the question, and then the output has to look similar to what the human has written. Like here's the steps to solve an algebraic equation, for example. Like if there's 4 steps, it's got to show those 4 steps.
So when it's doing stuff that it thinks is similar to that, it's going to try to follow that pattern.
Right. That's the ideal, except for
Got it.
the anthropic method that says that these reasoning models are actually alignment hacking. They're not actually doing it. They're just giving you a response that makes you think it's reasoning.
Got it.
Yeah.
Okay.
So it's not really.
So reasoning is alignment hacking. Is is reasoning to a model, or is it just, or is it, are we using a convenient word there? It's not actually reasoning, or
Well, so
are we
it's
not actually reasoning? We're just
it's reasoning in a computer science sense in that it's actually generating multiple responses. It's then looking at the responses and trying to come up with a structure of like this is how I arrived at this answer, right? And so the RLHF dataset is teaching it to how to think, how to generate results and compare them, and then combine it into the final output.
got it. Okay, cool. Kimi K2. Have you downloaded it yet and tried it?
No, you can't. It's too big. It's a trillion parameters.
All right, so it's not like DeepSeek. You have to go into the cloud for this one.
Yeah, no, you have to run on H100 or the
Got it.
parallel chips.
All right. Well, it's fun to see open source. We're always big fans of open source, and it's fun to see open source compete well against all the people that have closed off their models and their data sets.
Yeah.
Peter, thanks again. Be sure to follow us on Spotify, and if you like to listen to us there, we are there. You can leave questions and ask questions about anything specific to. I know we get a lot of interest in a lot of our sort of techie topics as well. So if there's stuff you want us to cover that's a little bit more technical, we're happy to do that as well. We will see you next time. Thanks, everybody.